Hey guys, welcome back to Nerdy Crew. So today we'll be solving another problem. Today the problem is of GCD, also known as HCF. Let's start by reading the problem statement. So we are provided with two integers n and m, and we have to calculate the GCD of these two numbers without using any library functions. Now let's read the definition of GCD. So the greatest common divisor of two numbers n and m is the largest positive number that divides both n and m without leaving a remainder. Here you are provided multiple examples. Do check them out. So now let's start understanding it with the help of an example. So now take a look over this example right here. We've got two numbers 36 and 60 and we have to find the GCD. By definition, we know that GCD means the greatest common number which is going to divide both of these numbers. So in this case, that is going to be 12. Now, let's call this first number m and the second number n. And we'll divide m by n until the remainder becomes 0. Now you will start observing some patterns here. But before that, you know that m is the dividend and n is the divisor. So here you can see that we are doing 4 iterations in order to get the final remainder as 0. So now look here. This is m while this is n. This is m and this is n. In every iteration, m is the dividend and n is the divisor. So now observe the first two iterations. This one and this one. You see that this n has become m here, right? This n has become m here. Similarly, this n has become m here and this n has become m here. So what is the pattern? We see that our previous divisor has become our current dividend. Our current dividend. Okay. So our previous divisor was previous n becomes our current m. Okay. This is our first observation. Now comes our second observation. Look carefully. Again observe the first two iterations. Here you see that this is the remainder in the first iteration. But in the second iteration, the same remainder becomes the divisor. And similarly here as well. This is the remainder in the second iteration, but it becomes the divisor in the third iteration. And this is the remainder in the third iteration, which becomes the divisor in the fourth iteration. Alright? Therefore, I can say that the previous remainder becomes the current divisor. Alright? The current divisor. So previous remainder, how did we obtain that? We simply divided n modulo m. And this becomes our current divisor, which means that now it will become our current n. This will be the updated value of n. Alright? So I hope you have understood this. Basically, based on these two observations, the algorithm is created. So now let's understand the implementation. First of all, you can see that we have to run a loop till n is not equal to 0. So we are running a loop till n is not equal to 0. So what are we doing in the loop? We are simply doing m modulo n in order to get the remainder, which is the current n. Current n, which means that this remainder is going to be the updated value of n, right? Which means your n will be m modulo n. Make sense? Then what is happening next? Now we are updating the value of m. What is m? M is becoming the previous value of n. M is becoming the previous value of n. But you see that n is now updated and I want the previous n. So what do we do then? Basically for that, I should have stored the value of previous n in some temporary variable before updating it. Then I update it, and then what I do next? I simply say that now my m is equal to temporary. My m is equal to temporary. Okay? Temporary means that now this is my new m, this 60. Okay? So this is what we are doing. And then at last I am simply returning what? See, my n has become 0. Therefore I am returning the value of previous n. That is, the previous n is always m. So I'm saying return m. That is how the code will look like. Okay, so I've written the same code here. Now let's try to run it. And we can see that all the test cases are passed. We can submit it as well. It's taking some time. And yes, it's submitted. So I hope that you have understood this lecture. Please make sure that you like, subscribe, and share it with your friends. Thanks for watching.